All right, so we're solving rational equations. We'll start with something fairly, we're probably pretty good at solving one like this. All right. Fraction equal to a fraction, what's that called? Or for the P? Proportion, yeah. So if it's a fraction equal to a fraction, we can solve it like a proportion. How do you solve proportions? Cross multiply, yeah. 8 times 6, and then 3x times 11. 8 times 6, 48. 3x times 11, 33x. Get x by itself. Divided by 33. Simplify that fraction. 48 and 33, both divisible by 3. Because 4 plus 8 is 12, and that's divisible by 3. And so we know 33 is divisible by 3. 11 and 16. And we found the answer to a rational equation. But it's a proportion when it's one fraction equal to another fraction. Okay. Now, with this one, we didn't have to worry too much about what x couldn't be because there wasn't an x in the denominator. If there's an x in the denominator, we've got to worry about these restrictions that happen. The reason we have to worry about it when an x is in the denominator is because what's the only number we can never divide by? 0, right? So if x were whatever would make that denominator 0 makes the problem impossible or undefined. So when we have an x in the denominator, we've got to worry about that. So when you get to example B here, 3 over x plus 1 is 9 over 4x plus 5. We have two occurrences where x is in the denominator. We need to find the restrictions. And you'll hear this several different ways. One way is to say the restrictions on the domain. That means what x can't be. You also might hear them called excluded values. There's several different names for these. So restrictions on the domain, you could hear them called that. You could hear them called excluded values. Both of those are the same thing. They just have different ways of saying that depending on what connotation you're in or what context you're in. So what to do to find those restrictions? You take the denominators that have x in them, only the denominators that have x, and set them equal to 0 to find out what would make that denominator 0. So this x plus 1 equal to 0, subtract 1. We know x cannot be negative 1. Well, there's another denominator that has x in it. So 4x plus 5. Set it equal to 0 and solve it. X cannot be negative 5 over 4. Those are our restrictions. Okay. That's not the answers. That's what the answers cannot be. Okay. If one of our answers happens to be one of those, we throw that answer out. That's what that's going to boil down to, really. So let's go back to the problem and let's solve it. So if we're going to solve that problem, I'll copy it down here so I don't have to scroll back and forth. Is it a proportion? Yeah, because it's one fraction equal to one fraction. Okay. How do we solve proportions? Cross multiply. So that's 9 times x plus 1 and 3 times 4x plus 5. And I'm absolutely fine with you skipping writing that step down and just go ahead and doing the distributive property. Okay, so 9 times x be 9x plus 9 be 12x plus 15. Once you've done that, get the like terms together, get x by itself. I'll move the 12x. Negative 3x plus 9 equals 15. Subtract 9. Negative 3x equals 6. Last step, divide by negative 3. X is equal to negative 2. All we got to do is check that against our restrictions. Remember, our restrictions were x can't be negative 1 and x can't be negative 5 over 4. Negative 2 is neither of those, so that means we keep that answer. If it is one of the, it does match one of the restrictions, then you throw that answer out. It's called an extraneous solution. So it more than likely, when you have a restricted value and an answer that match, you've probably got another answer as well. You got more than one. Most of the time, that's the case. I won't say it's all the time, but it's most of the time. Example C. 1 over 2x plus 5 equals x over 11x plus 8. So I got x's in the denominator, so that means I need to find restrictions. I'm going to use the word restrictions on the domain. That seems to be what the Algebra 2 end of course calls it. Now, you get into college algebra, we got some different names for it and things, but it seems to be that's what your end of course calls it most of the time. I won't say that that's always what they're going to call it. How do you find those? Yeah, take the denominator that has x in it, that equal to 0, solve it. Maybe we can solve that in our head. Subtract 5 divided by 2. Negative 5 over 2. Is there another one? Yeah, we got 11x plus 8. It's got an x in the denominator. Anytime there's an x in the denominator, you got to set it equal to 0 and solve it to get your restrictions on equations. All right, so subtract 8, divide by 11, negative 8 over 11. Those are our restrictions on the. Those are the things x cannot be. All right. Now let's find out what x is. What do we do to solve that? Is that a proportion? What's it take to be a proportion?
Fraction equal to a fraction.
A fraction, one fraction equal to one fraction. If it's that, then you can cross multiply to solve it. Okay. So I'm going to cross multiply x times 2x plus 5 and 1 times 11x plus 8. I'll write that out there just so. On this side, we get 2x squared plus 5x. And the other side is just 11x plus 8 because it's times 1. That's got an x squared in it. We've solved quadratics before. That's what x squared is. It's quadratic. What's it got to be equal to solve it? 0. So anytime you see an exponent higher, like this, an exponent a squared, a cubed, a fourth power, you got to get it equal to 0 to solve it. The previous example, you didn't have an exponent. You just had the plain x. You can just solve it like normal. Anytime you got an exponent on your variable, you've got to get it equal to 0 to solve it. You've got to remember that. And then just so get it equal to 0, subtract 11x. And I'm going to subtract 8. I'm just going to do that all in one step. You guys can handle that. 2x squared. 5x minus 11x would be negative 6x. And then we got the minus 8. And then if we're going to solve that using methods we know about solving quadratics. X method for factoring. Okay. So if I'm going to factor it, the first thing I always look for is no. Take the 2 out because it's the what? What's it called?
I can't think of what it's called.
GCF, the greatest common factor. That's what the 2 comes out and leaves you x squared minus 3x minus 4 because everybody was divisible by 2. Now here's the great thing about that. Because it's an equation, what happens to this 2? It just goes away, right? Technically, this is the math that makes it go away. It's getting rid of it. If it had an x on it, then it has to stay. It can't go away. But since it's just a plain number, we can just get rid of it, essentially dividing everybody by 2. So we get x squared minus 3x minus 4 equals 0. And x method of factoring, does that always work? No. It works on this one. What if it won't factor with the x method? Or maybe I can't figure it. Maybe it will, and I just can't find the numbers. Quadratic formula. That's also an option. So -4, multiply by -4, add to be -3, -4 and 1. I can go straight to my factors here, x minus 4, x plus 1. Set those equal to 0. X equals 4, x equals -1. All right. Does that match either of my restrictions? Either of those? No. Got to look at that and check them to make sure, because you may need to throw an answer out. Neither of these match a restriction, so they're okay. You keep both of them. So 2 answers to that one. All right. So if it's 1 fraction equal to 1 fraction, you can use cross multiplying to solve it. Much quicker, much easier than finding a common denominator and then solving it. If it's not just 1 fraction equal to 1 fraction, you can't do that. Like example D. 5 over x plus 7 over 4 equals -9 over x. So this one, we don't have just 1 fraction equal to 1 fraction. On this side, we've got a sum of 2 different fractions equal to another fraction. So cross multiplying is not an option here. Okay. What we need to do, though, is get a common denominator for all 3. If we can get a common denominator for all 3, then all we really got to worry about is the numerators. Okay. So least common denominator. Do they share anything? 2 of them share an x, so that's got to be part of the least common denominator. And then what's not shared? So the least common denominator is 4x. That's not too bad. This one's pretty easy on the common denominator thing. Now here's the shortcut on the restrictions. Once you get the least common denominator, that's what you're going to set equal to 0 to get your restrictions. Because that's still part of the game, because we got x's in the denominator, right? So take whatever your common denominator is to get your restrictions and set it equal to 0. And that one's a pretty easy one to solve. You divide by 4. X is 0. So the only restriction is x can't be 0 when we get done here. So if we know the least common denominator has got to be 4x, what does this first fraction need? A 4. So if the bottom gets a 4, the top gets a 4. What's the 7 over 4? What does it need? X. So bottom gets a x, top gets an x. -9 over x. They get 4s. So that gets us 20 over 4x plus 7x over 4x equals -36 over 4x. Here's the wonderful part. Once you get here, the denominators are all the same. The only equation you have to work is the numerators. So you drop the denominators and set up 20 plus 7x equals -36 and solve it. Because the denominators are the same. So now just the numerators is the only thing you got to work out. We've already done our work with restrictions on the denominator. And then just solve it for x. This one doesn't have a squared in it, so we know just solve for x like normal. So -20, -56, divide by 7. X is -8. not 0, so we keep it. If it happened to have matched the restriction and you didn't have another answer, then you could possibly have no solution. That happens. Not very much. It's very rare for that to happen, but it does. It could happen. So once you get the denominator the same, least common denominator, same thing from adding and subtracting. Once you get that the same, drop the denominators. Okay? No. Here you go. I'll take it for you. All right. So let's look at one that's maybe a little bit more to it. That one's a little too easy. 1 minus 8 over x minus 5 equals 3 over x. All right. One of those is not even a fraction. Or maybe it is. It's what, okay? It's 1 over 1, so it is a fraction. Common denominator. You've got fractions here. We know we don't just have one fraction equal to another, so we can't do cross multiplying. We need to get a common denominator. Do they share anything? No, they do not share an x. This is x minus 5. They are not shared. This x is separate. It's a completely different x than that one is because it has the minus 5 on it. It has to be match exactly the same. It would have to be x and then something with x parentheses, something else, to be a shared piece. So they actually don't share anything. So those are easier to get the common denominator on, in my opinion, because that just means you get everybody. Every denominator has to be part of it. So x minus 5, and technically there's also a 1 there, but what's 1 going to do? And it's just going to multiply and get x back. It's not going to change anything. Okay. So if that's the common denominator, we can get our restrictions. X minus 5 equals 0. What do you do with each of those? No, because you're going to have to undistribute. So if it's already in factored form like that, no, you can't divide by x. Oh my. Yes. So x can't be 0. X can't be 5. If we get one of those answers, we throw it out. Okay. And then you go and you fix the denominators. What does the first one need? It needs x and x minus 5. What does the second one need? X. And the third one, x minus 5. All the denominators are the same. So all you've got to worry about is what? The numerators. So once I've done this, I've got all the denominators having the same stuff on them. I can just look at the numerators then and solve that equation. So I got to distribute x squared minus 5x minus 8x equals 3x minus 5. So I just get x by itself, right? That is 15. Thank you. Yeah. Oops. Thank you. Just get x by itself? No, we got x squared, so we got to get it equal to 0. So move everything together that's going to get 0 on one side or the other. It doesn't matter which side. I'm going to go ahead and simplify the left side and get x squared minus 13x, and then move my stuff minus 3x. So that'd be x squared minus 16x equals negative 15. And then move the 15, addition. What are my options? X method for factoring or quadratic formula. I'm going to work this one both ways so we get a view of both of them. So if I do X method of factoring, multiplying to be negative or positive 15 and adding to be negative 16, negative 15, and negative 1. So our factors would be x minus 15, x minus 1. We set each of those equal to 0. And x equals 15 and x equals 1. Doesn't match either of our restrictions, so that's okay. If you struggle with factoring, quadratic formula will work. X equals negative b plus or minus radical b squared minus 4ac divided by 2a. Work that out. It should give you the same answers. 16 squared, 256. 4 times 15 would be 40 and 20, 60 over 2. So that's 16 plus or minus the square root of 196. Square root of 196 is 14. So 16 plus 14 over 2 is 30 over 2. That's 15. 16 minus 14 over 2 is 2 over 2, which is 1. Same two answers with the quadratic formula. So keep in mind, factoring works some, but not always. So you've got to have that quadratic formula method or some other method to solve those quadratics. Do a little tougher one here. F. 6 over x minus 3 equals 8x squared over x squared minus 9 minus 4x over x plus 3. All right. This common denominator is going to be the first step here because we got more than one fraction on each side. To find the least common denominator, before I can start looking for what they share, what do I have to do first? You got that x squared minus 9. That should make me think that that one would do what? Difference of squares. It'll factor. So anytime you look at the denominators, you've got to really every time check for factoring. Our denominators so far have been really simple things that didn't look like they would factor at all anyway. But you really should look for that every time. So what does x squared minus 9 factor as? Yeah, x plus 3 and x minus 3. So I'm just writing that right underneath it. That's really what this denominator is. It's x plus 3 and x minus 3, which is nice because this one's sharing that one and that one's sharing that one. So the common denominator is what? Yeah, x plus 3 and x minus 3. And then we don't need anything else because that got both shared pieces. And that was matching what this denominator was. Okay, and then so we can get our restrictions real quick from that. Or excluded values, whatever you want to call them. X plus 3 x minus 3 equal to 0. Set each factor equal to 0. X equals negative 3, or x cannot be negative 3. X cannot be positive 3. Those are our restrictions. Then we go up here and we fix the denominators for the fractions that need fixing. So this one needs what? It needs an x plus 3. So the top gets an x plus 3. The second fraction, 8x squared over x plus 3x minus 3, does it need anything? No, so I don't have to do anything to him or her, whichever one it is. Okay, and then what does the last one need? Needs x minus 3. So we're going to add an x minus 3 to that and to the top. Now everybody has the same denominator. All I have to do is the numerators. Once I get the denominators fixed, all I have to do is the numerators. So top part of this one is 6 times x plus 3 equals, I didn't do anything to 8x squared. It's a minus sign, so that's minus 4x parentheses x minus 3. So this blue thing here, that is just the numerator equation. That's the one you got to solve. You've already done your solving with your denominator for the restrictions. Distribute where it needs distributing. So it'd be 6x plus 18, 8x squared minus 4x squared plus 12x. Simplify if possible. 8x squared minus 4x squared is 4x squared. And then what do we need to do now? To do what? Equal it to 0. Why do we need to get it equal to 0 again? It's got an x squared and it's quadratic. It's got an exponent bigger than 1, then you need to get it equal to 0 so you can solve it using the methods we already know how to do. So I'm subtracting 6x, and I'm going to go ahead and subtract 18. There's a 0 plus 6x minus 18. Could I make that easier on myself a little bit? Is there anything I could divide everybody by? 2. They're all even, right? So I could divide everybody by 2 and get that to be smaller numbers. So if I do that, I'm going to even divide the 0 by 2. That's what makes it legal to do that. And that's 2x squared plus 3x minus 9. Options. X method, I think, multiply to be negative 18 and add to be positive 3. Anything that does that. Negative 3 and 6 does that. So yeah, X method works here. Quadratic formula would also work. I always try to factor first. And if I don't think of the numbers like within maybe 10 seconds, I just go to the quadratic formula. I don't even spend a ton of time trying to factor it. Because I'm just looking to solve the thing. I don't really need it in factored form. I just need answers. And if I can't factor it quickly, I usually just jump right to a quadratic formula. That'd be negative 3 and 6. So that I can't go straight to my factors here. I got to go 2x squared plus 6x minus 3x minus 9 because it doesn't, has something else in front of x squared. Grouping 2x, x plus 3, negative 3, x plus 3. So I get the factors 2x minus 3 and x plus 3. What do I do with each of those factors? Equal them to 0. So 2x minus 3 equals 0. And x plus 3 equals 0. So this one's going to be, add 3. x is equal to 3 over 2. This one's a little shorter. X equals negative 3. Do either of those match a restriction? The negative 3. So we just throw that one out. Just put an X across it like that. So I can still see that you got that answer, but that you're throwing it out. That's a good way to, that don't just scribble it out or erase it. Show me that you got that as an answer, but you're throwing it out because it matched a restricted value. 3 over 2 we keep because it doesn't match a restriction. It's good. You could also do that with quadratic formula. When it's got a leading term other than 1, most of the time quadratic formula and factoring take about the same amount of time or work, whichever one you're better at. But again, sometimes factoring just, it doesn't work, and you've got to use quadratic formula to get there. Let's look at one exceptional one before we get out of here today. This one's a little shorter. I'll make sure I show you one of these before you get out of here. A little easier on the least common denominator here. Really, that's 7 over 1. So the common denominator would be just x minus 2. It's the only thing there other than the 1. Okay, so restriction, x minus 2 equals 0. X can't be 2. And then fix, only one fraction needs fixing. It's the 7. What's it need? X minus 2 on top and bottom. So that's 5x equals 7 times x minus 2 minus 10. We're going to work this one out. 7x minus 14 minus 10. Our job's get x by itself. We don't have to get this one equal to 0 because it doesn't have an x squared in it. So we just solve it for x like Algebra 1 style or 8th grade math style. So subtract 7x. It's negative 2x. And then negative 14 minus that shouldn't be a minus, guys. I miscopied the problem. Let's make it a plus. That way it does what I want it to do. Make it a plus. I'm sorry, I miscopied my problem from my notes. This plus side there. What does that do? Negative 14 plus 10 is negative 4. And then when I divide, what do I get? 2, which is the same as my restriction, right? That's the only answer I had. I'm throwing it out, and I don't have another answer to fall back on. So that would be a no solution case where that happens. All right, so assignment for this lesson, page 593, 4 through 25. There are several there at the beginning that already have, that are either a proportion, or they may already have, maybe a one-step common denominator deal. So a lot of the ones at the beginning there are pretty easy. You get down into the 18, 19, 20 through 25, you're probably going to have to do some factoring and finding a common denominator. So